In this video, we're going to explore relationships between tangents and circles. Now, as a reminder, a tangent segment is a segment that will intersect a circle at exactly one point. So here what we have drawn is we have a circle. We've got a radius given to us, and then we also have this tangent that's drawn here. Now, we already know that a radius and a tangent will be perpendicular. That's something we've explored in a previous video. What we want to look at now is something called a tangent chord angle. So a tangent chord angle is made up of a chord and a tangent. That's how we get the name of it. So let's say we have this tangent chord angle right here. So CD is our chord and CE is our tangent. So the angle formed between that chord and that tangent is 58.28 degrees. What we want to then do is take a look at our central angle, and that angle is 116.57. It doesn't seem significant, but take a look at when we have that central angle there. That means that that arc here, that central angle cuts off, is going to be exactly the same. So arc CD from point C to point D will be 116.57. The tangent chord angle is 58.28. Let's move some things around and see if we can get, a nice measurement there. This is 135. This angle, half of 135 is 67.5. So the tangent chord angle is going to be half of the measure of the arc that it cuts off. Very similar in structure, anyway, to the inscribed angle that we've already explored. So let's take a look at some examples with that. So for instance, here we want to find arc BC. So we know that this arc right here is 11x minus 7, and we know that this angle, which is a tangent chord angle, is 5x plus 4. So we want to use the idea that we just explored with the tangent chord angle being half of the arc to set up a problem like this. So what we're going to do is we're going to take half of the arc, 11x minus 7, and that should equal my tangent chord angle. Now again, I don't think I want to distribute that 1/2 because I'm going to be introducing fractions that I really don't want. So I think probably my best option is to get rid of that 1/2, multiply both sides by 2. $11x minus 7 equals 10x plus 8. And then we're going to solve. So I'm going to bring the 10x over to give me 1x, and bring the negative 7 over to give me 15. We want to find arc BC. So once I have that 15, I've got one of two things that I'm going to do. I'm going to go ahead and solidify that idea of the tangent chord angle being half of the inscribed arc by actually taking that 15 and plugging it in to the tangent chord angle. So if I do 5 times 15, that's 75, and add 4, I'm going to get 79 degrees. That's my tangent chord angle. My arc that's cut off is double that. So when I take 79 times 2, I end up getting 158 degrees. So that's how tangent chord angles basically are going to work. That once we have that inscribed, the intercepted arc, we can take half of that, and that's going to give us our tangent chord angle. And in the second part of this video, we're going to be looking at what's called a tangent-tangent angle. So not made of a tangent and a chord, but made of two tangent segments. Looking at the diagram that we currently have, we have two tangent segments, a segment here DC. This one might be tough to read, but that's a point E down there. So segment CE is also a tangent segment. So those tangents are given to us. I can deselect them if I want. Let's reselect and make sure that they're there. I can move this point around, and it doesn't change the fact that these are going to be tangents. It might just make it clearer to read them. So we want to know the measure of the tangent-tangent angle, which is told to us as 56.53 degrees. We have our central angle measured there. And we have two central angles. We have this major angle, which gives us our major arc. I'm not worried so much about that one. I'm really more concerned about this minor arc, because this minor arc right here and the central angle should be exactly the same. Now, if I can find the measure of this and figure out a relationship between that, that's really what I'm trying to do here. So let me see if I can change some things around a little bit. Oh, I just had a nice number. As you see, like when we're changing that size, that central angle is going to change, as is the tangent-tangent angle. Actually, let's go back to that, 40.6. We'll call it close enough, 40.05. So 40.05 is my tangent-tangent angle. And again, this minor arc has the same measure as the central angle. So what I'm trying to do is figure out the relationship here. And it looks to be that if I take this central angle, same as the minor arc, and add in the tangent-tangent angle, I'm going to get 180 degrees. And so that's a relationship between the tangent-tangent angle and the minor arc. Just as a side note, too, these tangent segments here, segment DC and segment EC, must be congruent. If they're coming from the same point of, outside the circle and going to the same circle, then those segments have to be congruent. So again, let's apply those concepts, those ideas, to try and find some geometric quantities here. So number 10, I think, is a really fitting problem because we've got the tangent-tangent segments drawn in. We've got the measures of those in terms of x. We also have our tangent-tangent angle in terms of x. And we're trying to find the measure of arc BEC. It really kind of ties everything together from the last few sections. So first things first, I know that these two segments, the tangent segments, have to be congruent. So I set them equal. 2x plus 4 equals 4x minus 16. Bring the 2x over and bring the 16 over. So then x is 10. And if I want to, I can verify and plug them in. This would give me a 24 as with that. What I want to do next is plug it into that angle, which is 7x plus 10. So 7 times 10 is 70. Add 2, that gives me 72 degrees. So that's the tangent-tangent angle. The minor arc adds up to 180 with that. So if I take 180 minus 72, I'm going to get 108 degrees. So again, that's that minor arc right here. That's not what I'm trying to find, though. I'm trying to find the measure of BEC. So starting at B, going through E, and ending at C. So if this is 108, I can find 360 minus that to find what's left over. And so that would be 252 degrees. All right, so again, tangent-tangent angle is going to be the minor arc subtracted from 180. The tangent-tangent segments are equal. And the tangent chord angle is half the measure of the intercepted arc.